Hello everyone. Last time we talked about finding limits using graphs. This time we're going to get back there at finding limits using graph, but involving now infinities. Take note that infinities are technically not numbers, and what we're going to get as results after taking the limits of certain functions. When we get infinite limits, we are not talking about numbers. We are talking about descriptions about the behavior of that function when x approaches a certain number. So let's get started. Let's take a look at this very interesting looking function. You will see there that it is not really the typical function that you see because it has many terms. And at certain parts of this function, there are jumps, uh, and certainly okay, it is odd looking. Right? There's no symmetry also. Now, we are tasked to find what is the limit of this function as x approaches -3 from the left. Okay. Do note that this function has certain, for example, here. So please note that we have arrowheads here. Okay, we have arrowheads. This has an arrowhead. This also has an arrowhead. Uh, this one here has an arrowhead. This one also here, it has an arrowhead. No, here, there's no arrowhead here, but here also you will find an arrowhead. So you will see that these functions continue indefinitely at certain points. Now we are tasked to investigate the limit of this function as x approaches -3 from the left. So here, okay, here is our point of interest, -3, and not just that, but from to the left of that, to the left of that. Now it's very easy to see that the function goes on up, 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 and up. Okay? This means that this function extends without bounds to large positive numbers. Okay, you can think of like 1 billion, 1 billion, that large. All right. But again, we are asked, so how does this function behave when x approaches -3 from the left? Here we can say positive infinity. Okay. Here we can just describe it by saying positive infinity. Again, okay, let me remind you that positive infinity is not a number. So the limit here is not a number, but a description. What is that description? That this function extends indefinitely into very positive real numbers when x approaches -3 from the left. Now, if you're going to ask, how about the limit of this function as x approaches -3, this time from the right? So again, our point of interest is -3, but to the right of that. Now you will see that it has the same description. The function extends indefinitely up. So it gets, the function values get like large positive numbers. Again, like 1 billion, 1 billion. So how do you describe that? How do you describe that? You just say, well, it is positive infinity. You got that from the graph. Again, because the function behaves such that as you get nearer to -3 from the right, the value of the function gets bigger and bigger and bigger positively. Now, here again is this cute little question. What is the limit of f then when x approaches -3? Okay. Neither left nor right. We remember again from our past lesson that this can only exist if the left-hand limit, and the right-hand limit are in agreement. If they are in agreement, then the function is said to have an infinite limit at that number. Sir, because they are in agreement, I can safely say that the limit of this function as x approaches -3 is positive infinity. The reason? Because the left hand and the right hand limits are in agreement. We cannot say they're equal because again, they're not numbers. All we what we can say by this is that when x approaches -3, whether from the left or from the right, the behavior of the function is the same. It increases without bounds. Okay, so when we get a result that is it increases that is positive infinity, we can say it increases without bounds. Right. So let's move to the second number. How about at 0? All right. How about at 0? More specifically, -0 from the left. So our point of interest this time has shifted from -3 to 0. Our point of interest now is at 0. Not just 0, but for 1D, at least, it is from the left. Okay, let me just make some adjustments. This is 1E, and this is 1F. All right, so by looking at the graph, we can say that as I approach 0, but from the left, the function behaves such that it gets values that are larger and larger but negative. All right, you'll be able to see that the behavior is the function gets larger and larger and larger, but negatively. You can think of negative 1 billion, 1 billion. That large, that large. So we can say that is negative infinity. Again, negative infinity here is not a number. It only means to say that the function increases without bounds negatively. Negatively. Now, on the other hand, as I approach 0 from the right this time, the function is also, the behavior of the function is also obvious. This time, it goes back to getting larger and larger and larger, but positively. But positively. So here we can say, the limit of the function as x approaches 0 from the right is positive infinity. Again, this is not a number, it's just a description of how the function behaves. And so we get to the last question. So what is the limit of this function as x approaches 0? This time, no left, no right, just at 0. Recall that your left-hand limit, sorry, recall that your left-hand limit is this, and it is negative infinity. And recall that your right-hand limit is this, which is positive infinity. Do they agree? Sadly, they do not. They do not. And therefore, we simply say does not exist. Why? Because the limit of f as x approaches 0 from the left is not equal to the limit of f as x approaches 0 from the right. And because of that, therefore the limit is said to not exist. So again, remember we can take the limit of functions as x approaches a certain number, whether from the left or from the right, or exactly at that number by looking at graphs. And in this lesson, more importantly, by looking at the behavior of the graph, whether it increases manifold positively or whether it increases manifold but negatively. In the next lesson, we will show you how to compute for infinite limits even if we do not have graphs. Even if we do not have graphs. That's all for now. See you next time.